The last two problems that we dealt with had to do with projectiles. Okay, things that travel a path in the air, they reach a maximum height, and then they come back to the ground. Okay, so we dealt with breaking down components of an initial velocity. Okay, and it's something that I want to point out is that when you break down a vector, when we find components of a vector, those components will still have the same units as the original vector. Okay, so if you break down a velocity vector into x and y components, those components will also have meters per second as their units, or kilometers per hour, or whatever the unit was. Okay, so I don't know that we need to do any trig review. I felt like you guys were okay with it as we went along in the worksheet. Is that a yes? Something that I want you to remember is that when you're solving for a side, you use the regular tangent, cosine, and sine buttons. When you're solving for the angle, you have to use the second button. Okay, so tangent, -1 or whatever. Okay? Clear? Yeah. All right. Do we need to do a component example, or is everyone pretty good breaking down component vectors?
That's easy.
Good? Okay, if we need to do any, let me know so we can get it done. All right. Oh, we don't need to do this one either. Okay. So we're going to start talking about projectile motion and what it is, where we see it, things like that. Okay, so projectile motion means objects flying through the air in 2 dimensions. Okay, these are some examples of projectiles. Okay. When we say flying through the air in 2 dimensions, we mean to say they are moving both vertically and horizontally. Okay. In the kinematics we've done thus far, we've seen things go straight up in the air and come straight back down. And we've seen things maybe driving and come to a stop, or moving horizontally. We haven't seen it both ways yet. So now we're looking at things that are moving freely through the air in 2 directions. All right. When we talk about projectiles and we talk about throwing a ball or punting or kicking or doing something to an object, we're not concerned with the process that it takes for the object to reach the air. Okay, we don't care about the actual motion of the punt or of the throw or of whatever it may be, the slingshot. Okay, we don't really care about that. We care about the object once it begins freely moving through the air. Okay, so once it's detached from that original force. Okay, we're only looking at the object as it flies freely through the air. Okay, yeah, we talked about that. When something's moving freely through the air, that means gravity is constantly acting on it. Okay, it's constantly acting on it all the time anyway. But when we're talking about things in free fall situations, that means the acceleration is going to be gravity. Is gravity a vertical or a horizontal component? Vertical. Okay. So when we look at projectile motion, we're going to be looking at vertical things totally separate from horizontal things. So the acceleration for all of our vertical equations here will be gravity. Okay? Does that part make sense? Okay. When something's traveling in a projectile, the actual path it takes through the air is called a trajectory. Does anyone have any idea about what that looks like? Yeah, just like that. Okay, if you have something you have an object that starts here, it's going to move through some path, some kind of arced path. It reaches a maximum height, and it begins to fall on the other side. Okay, these 2 halves of the path are totally symmetrical. Okay, so trajectories can either be very, very, what's the opposite of steep?
Slope. Shallow.
Shallow, yeah.
Wide.
Yeah.
Small.
I don't know. What is the opposite of steep?
Steep?
Yes, the opposite of that. 3 people said steep. Flat. Yeah, I guess.
Hill.
I don't know. Anyway, they can be not very steep or they can be really steep. Okay? Either way, they're spread out. Well, horizontal acceleration is not 9.8. So we're talking here, we're looking at vertical acceleration is always 9.8. Like if you speed up in a car, you would have a change in velocity. Yeah, but we'll talk about horizontal acceleration for projectiles because it's different. All right, moving on. Okay, listen. Okay, we're going to talk about projectiles in two totally separate contexts. Okay, Galileo was the one that predicted and kind of finalized this. He was able to show that you can study projectiles by breaking down vertical and horizontal components totally separately. So when we're looking at projectile paths or trajectories, we have to analyze vertically and horizontally. Okay, they are two totally separate. We have two different sets of equations. We have different ways we solve for horizontal and vertical. Okay, so we've got to break them down. You can move to the front. Here's our new vertical equations. Okay, and they have a couple more subscripts. Look at the new subscripts that are added with them. Y. Because Y is vertical, right? So that means these are the vertical equations. So VYF would mean vertical velocity final. Okay, does that make sense? I'm going to zoom it in a little bit.
Thank you. I was just bored.
And with our coordinate system, we have to note some things about our origin. Okay, since the motion begins at the origin coordinates are normally what? 0, 0. So we're going to assume that x sub I equals 0 and y sub I equals 0. What do you think x sub I means? Yeah, horizontal distance. Okay, so x sub I means horizontal initial position. Y sub I means vertical initial position. Okay, and since we're starting our motion at the origin, both of these need to be 0. Okay. So for projectiles, we don't use D anymore to represent distance. We use our X and our Y because our distances must be broken down into horizontal and vertical. And our last assumption has to do with acceleration in the horizontal direction. Okay. As something is flying through the air, it's not going to be speeding up or slowing down horizontally, right? It shouldn't be having any issues there because we're assuming air resistance is negligent. So we're going to say that acceleration in the horizontal direction is constant throughout the entire thing at 0. So there's no acceleration in the horizontal direction at all. Okay, so in our equations, a sub x would equal 0. And I'm going to show you how we kind of account for that in our equations. Okay, so these are things that we need to do when looking at projectile problems. Listen. First and foremost, we have to read the entire problem. Don't get halfway through and assume you know what it's going to ask and start solving, okay, because you might be wrong. Read the entire problem. We have to choose an origin and an xy coordinate system. X to the right is positive, up is positive. That's what our normal coordinate system is, right? To the right is positive, up is positive. We analyze x and y totally separately. We've got to learn that these two are completely separate of each other. Okay? We make our list. What's it mean? What's it mean for the list?
What you know.
Yeah, what you know. Okay, so if I have v sub y1 equals v sub x1 equals blah, 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 that's my list, okay? Let's see. Okay, here's a couple things that we need to remember. Horizontal velocity, v sub x, is going to be the same throughout the entire problem. So v sub xi equals v sub fx, or v sub whatever, however I said it. Okay, v sub xi and v sub xf should equal each other. The subscripts and the order you put them in doesn't really make a difference, but sometimes I get it mixed up. V sub yf equals 0 at its highest point. So let's think about when this projectile reaches its peak height. We know at peak height its velocity is what? 0. Its vertical velocity is 0. Horizontally, it will keep moving. Then it will start to drop. Okay? So at its peak height, which will be the first half of the projectile, v sub yf will equal 0. Okay? Its final vertical velocity at peak height will be 0. Okay. The velocity before hitting the ground is generally not 0. Okay, so when we're talking about final vertical velocity, we're not talking about when it hits the ground. We're talking about the very, very instant before that. It's traveling at a certain speed. Okay, so typically your final vertical velocity won't be 0 if it's just before hitting the ground. Does that make sense? We're not talking about finally when it comes to a stop. We're talking about the instant before it hits the ground. Okay, think before choosing an equation. You might have to use a series of equations when solving these problems. It might not be as easy as one and done. Alright, so stunt driver speeds horizontally up a 50-meter cliff. We want to figure out how fast he must be going. So if we want to find out how fast the motorcycle must be traveling, what variable does that mean we should be solving for? Okay, we're going to be solving for a velocity. What type of velocity? When he leaves the cliff? Initial. Is it going to be vertical or horizontal?
Horizontal.
Good, horizontal.
Okay, but
So we want to find out what speed he has to be when he's leaving the cliff to make it 90 meters away. All right? So what else do we know from our equation? What other variables can we plug in here?
50 meters.
Okay, that's going to be y final. And is it going to be positive 50 or negative 50?
Positive.
He's landing above where, yeah, he's landing below where they started at the origin, landing down here, so y final's got to be negative 50. Okay? So what about our x final?
It's going to be 0.
It's going to be 90, because horizontally he's moving in the positive direction 90 meters.
And that equals the t, the x on t.
Mm-hmm. It's a little bit thinking, yeah.
What's the xit? Is that time?
Uh-huh.
Time?
Down here?
Yeah.
Uh-huh. But we don't have time. So we're going to use this equation right here to solve for time. Is this equation using vertical or horizontal components? Right here.
Vertical.
Why? So it's vertical. Time is the only one of our variables that we can use in both sets of equations. So time is often the connector between our vertical and our horizontal equations. Okay? So we don't have time, and we don't have the ability to solve for time since we don't know v sub xi from this equation. So that means we need to look to our vertical equations to try and figure that out. Okay? Yeah, what do you think Vy initial is?
50.
0.
0.
oh, is that an I?
Yeah, it should say VIT. I must have left off that one. Good news is we don't.
What?
It should be VYI times time. Okay, but it doesn't matter because we're leaving that off anyway. V sub yi is 0 because when it initially leaves the cliff, it has no vertical velocity. It's only moving horizontally, right? It's just the motorcycle that's giving it any velocity, and that's only horizontal. So V sub yi is 0, so we can leave that off too. So now we have plus 1/2. What's our A? What's our acceleration for vertical? Yeah, negative 9.8 times t squared. Okay, so now we're going to have negative 50 equals negative 4.9 t squared.
That equals,
Divide that 4.9.
no, add
Now, how do we get, yeah, we divide by negative 4.9.
oh my god.
Okay, because that 4.9 is connected to the t square. We can't get rid of it if we don't divide it over. Okay, so tell me what we get for our final time.
3.2.
3.2. Great. Okay, are we on agreement thus far? Anyone have questions as to how we got here? We solve for time, then we plug into our horizontal equation to solve for Vxi. So that means this guy had to leave the cliff at a speed of 28.1 meters per second in order to land 90 meters away. So go ahead and get this problem copied down, draw your diagram, and start picking out variables that you know. What can we pick out from our,
YF.
okay, we know y final is equal to what? Yeah, good. Does everyone see where that came from? Okay. What else do we know? Good. Vxi. 3.21. Because it says we have a horizontal velocity. Okay? That's what it's thrown with. That's initial. Okay? It's what it started with.
That's all we have.
So we're solving for time.
Is there a YF equals VXIT?
Mm-mm. What do you think? What do you suggest? Take a look at your equations. Try and find one that we can use. Remember that our other,
Well, we need to find X.
we have 9.8 too. We have our acceleration for our vertical acceleration.
Don't we need to find XI? Or not?
You can use a vertical equation because time is the one connector between the two sets of equations. Okay, you have to use time in both. Do you have a vertical one that you think will work?
The second one? Or the first one? First, wait. No.
Do you know?
You don't know.
No.
Nope.
Third one.
I don't know.
So, does this rock have any vertical velocity to start out with?
No.
No, because it's being thrown horizontally, so it has only horizontal velocity. So that means V sub yi equals 0. Okay, and the reason this is because this rock specifically says it is thrown horizontally.
So do we know Y left or Y left?
So the second one? Wait, do you know?
Yeah, the second one. We know y final.
That's right.
We know y initial is 0 because we start at our origin. So we're going to use this equation. Y sub f equals yi plus v yi times time plus 1/2 at squared. And we're going to solve for time. We know y final equals negative 24, 0, 0, 1/2, negative 9.8 times squared. All right, so we get 2.2 seconds for our time. We're going to have a couple other questions that we're going to answer. So make sure that you kind of keep time circled so you know what it is. Okay, I'm going to clear this screen.
So this is still example 2.
Mm-hmm.
What'd you ask?
I'll leave the numbers.
We were still waiting at sample two.
Yep. Same problem. We're just going to answer a couple more questions about it. You good? Okay. So we have two more questions we want to answer. How far from the base does the rock land, and what is the final vertical velocity of the rock? Okay, so let's go ahead and start with this first one here. How far from the base does the rock land? Can someone tell me my variables that we know again? That way I have it.
YF.
Negative 24.
VXI. VYI.
Okay. And time was what?
2.2 seconds.
Okay. So let's go ahead and look through your equations to see what you can find to help you solve for x final. Do we see why we're solving for x final? Good.
Can you just make like a triangle down?
So x final equals Vxi times time. Because we now have Vxi and we solved for time. So x final equals 3.21 times 2.2. Okay. What will the units be here? Just meters. Just meters, because it's a distance.
Why wouldn't it, if we're finding velocity find, vertical velocity find, why isn't it the Vy?
Which one were we solving for?
Or like the question was, what is the final vertical velocity? Why didn't you do like?
Oh, we were solving for this one. Next one, we'll do that one. Okay? Yeah, good idea. Final vertical velocity. Next part of the problem, we're going to solve for V sub, what, Miranda? Yeah. Good. Next part, we're going to solve for V sub YF. So find an equation that we can use to solve for that. Yeah, the first one. V sub YF equals V sub YI plus AT. And in this case, can we drop the V sub YI?
No. Yes.
Yeah, because it's 0. It's 0. Okay, so V sub YF equals 0 plus what's acceleration in the vertical direction?
Negative 9.
Yep, negative 9.8. And we'll take that times our time.
Negative 21.56.
Okay.
Ooh.
V sub YF, negative 21 point what? And what's the units? Good. Okay, does it make sense here that this velocity is negative? Yeah, it's going down. It's going in the downward direction. And we chose down to be our negative direction. So yes, it makes sense.